Hello, everyone, and welcome. Today, we are excited to talk about backend standardization with MCP. I'm Tai Hoshino, a tech PM here at Mercari.
And I'm Katie Hockman. I'm a software engineer at Mercari.
Let us first introduce ourselves quickly. I'm part of platform. I'm tech PM for the platform product. I joined Mercari in January this year. And before that, I was TPM in Postman and support engineer at Dropbox. At Mercari, I'm driving a few cross-organizational projects, including the backend standardization effort for the entire Mercari group, which is what we'll be discussing today.
Yeah, so I'm Katie. I'm a software engineer on the platform side at Mercari. Prior to that, I was at Google in the US, working on the Go language team. I was also a manager at Datadog, leading their observability libraries for Go tracing. And I just joined Mercari about 1.5 years ago when I moved from the US to Japan. So I'm still learning Japanese. Nowadays, I'm working on some of the kind of core foundational systems, things like notifications and media management within the platform.
Let's start with why. I will first talk about the challenges with standardization, including problems that we see due to lack of standardization, and why it's hard to drive standardization across the company. First, problems with lack of standardization. We mainly see 3 problems which are connected to each other. Firstly, domain silos. This is a typical consequence of company scale up from startup size to mid-size where speed and autonomy are prioritized. Each engineering team selects their own architectural design and develops differently. Naturally, this would lead to inconsistent structure across the company. Then, as the company scales up further, maintenance costs associated with individual teams' assets beyond business logic become significant, and this would slow them down. Let me give you a few actual examples that we see at Mercari. We had inconsistent logging and tag standards, which made it extremely difficult to do any cross-service debugging. When we had reorganizations, any changes in service ownership led to substantial onboarding costs for the new team. And we saw teams spending hours or even days on alignment discussions, just debating over what libraries or patterns they should use. Obviously, this all time is not spent on building any business value. So standardization is a key to solving all these problems that I just described. Firstly, consistency will be the foundational outcome of the standardization. With consistent architecture across the cognitive load, across the company, we can achieve faster onboarding and reduce cognitive load. These values do not only benefit human engineers, but also benefit AI agents. Learn once, code anywhere is not only for human engineers. Once we have a company standard for how to build stuff and drive consistency across the company, we can provide that standard as a common context to AI so that AI would generate codes in compliance with the standard. Reduced cognitive load would also be true for AI. Once we can establish a reproducible way to provide a common context to AI, the dependency on individual prompting techniques become much less, and instead we can rely more heavily on a common asset to provide a context. But standardization is not easy. Actually, it is very challenging to drive company-wide standardization effort. I think there are a few reasons. Firstly, migrating to a company standard requires large costs. We typically see engineers need to spend more than 1 week for manual code changes, and then comprehensive testing is required to ensure nothing breaks. This ties to the second point of no clear ROI. It's hard to justify such large investment for the benefits that we cannot clearly quantify. Lastly, standardization effort comes with the code start problem. This is where certain benefits, such as reduction in onboarding cost, can only be realized after majority of the services has adopted or once network effect is in place. So far, we've discussed why standardization is important and what are the challenges with standardization. With AI becoming more and more central to how we work, specifically how AI is changing the development workflow, we are actively exploring ways to solve these challenges with help of AI. By the way, according to the Stack Overflow developer survey this year, 84% of programmers are currently using or plan to use AI for coding. This number clearly shows that AI-assisted or AI-driven development is already default. And I believe many of you here are already using AI for coding. Mercari is not an exception, and we are shifting to become an AI-native company. We are making bold investments in AI. This includes launching an AI task force, providing group-wide access to AI tools, and actively driving company-wide knowledge sharing through AI hackathons, demo days, and lightning talks. Our platform organization hosted the platform-wide AI hackathons over 2 days back in June. And we ran weekly Friday last quarter, which is a half-day hackathon in Friday afternoon. These activities helped incubating many new capabilities and allowed people to explore with curiosity and learn from each other. In terms of how AI is used in development workflows, I believe there are 3 typical use cases. Firstly, as a coding assistant to help you implement a specific function. This is a very direct one-to-one instruction, and human engineer is in the driver's seat and holding the steering wheel. This is where your prompting technique becomes important. Secondly, as an autonomous agent. This is a significant step up from an assistant. You don't just ask it to write a single function, but instead you give it a larger goal. For example, if you say, help me debug this problem, you're expecting it to autonomously investigate and run a series of steps on its own to find the root cause. AI would take a complex task and then break it down into smaller executable tasks. In this case, AI agent is like a taxi driver, and human engineer is a passenger who tells the driver a destination. So this is where the providing the right context to AI is more crucial than prompting techniques. Like you expect a taxi driver to know the area he's driving or has a map. And thirdly, as a knowledge gap. You can just ask it, tell me about this code, and it can explain it in natural language. And I often use it as a knowledge bridge, and I take advantage of this aspect of AI to get more understanding about code base. So in the perspective of driving standardization, we think an autonomous agent is a game changer and has a potential to massively reduce the cost associated with migrating to company standards once it's given the right context, because it can implement code changes autonomously. Additionally, we can use AI as a knowledge bridge to help in onboarding to the standard. So in short, AI has a potential to help us scale standardization. So as I mentioned, context is a key for an autonomous agent for it to perform reliably. Now, I'd like to hand it over to Katie. She's going to explain more about these limitations of AI when it lacks context and how we can solve this problem using a technology called MCP.
OK, hi. So I know there's been a lot of AI talking today. And I am going to keep talking about AI, but I want to give a very specific use case on how you could do this. I think we talk a lot in abstracts. So With this, I want to talk about something called MCP. That's short for Model Context Protocol. There's actually been a number of people who have talked about MCP. I know Kimura-san this morning was talking about MCP, and we've been talking about, oh, you have to give agents context. Well, this is the tool that's going to help with that. So I'm going to talk about this at like a 101 level. I want everybody to come out of this knowing what an MCP server is. And then we're going to do the bold thing of live writing one and using it. So give the demo good vibes so that it runs. Thank you. OK, so maybe you've tried using AI for coding in the last year. Probably many of you have. But I'm assuming you ran into at least one of these problems here. One thing that you're going to notice with AI is that it's going to hallucinate pretty frequently. So it may just completely straight up lie to you. And that's going to create a worse result than if you had just done it yourself. So that may be one experience that you have. Another experience is maybe it is technically correct, but it's just too general. So you're asking something that requires some kind of domain-specific context, where even if it's technically correct, it's not really solving your problem. Or perhaps lastly, as we've talked about with some of this agent work, agents have to be given the tools to do the job. And so you may have noticed that out of the box, these agents don't have enough power on their own, and it's just regurgitating what it can find online, and maybe that's insufficient for you. So I want to show this example to see maybe what you would have done and what's happening kind of under the hood within the IDE. So most modern IDEs nowadays have actual language learning models or LLMs built directly into the UI. So we're going to call this the AI agent. It's what we talk about, this autonomous agent we've been talking about. That's this. So like I said, for those of you who have tried it, maybe you've had a few problems. So out of the box, it's really going to only be able to access a few things. Local context state, so maybe the code that's up on your machine at that time. And it can maybe do like a basic internet search, and then whatever is sort of by default installed in the agent. So at best, that might be kind of unwieldy, and at worst, it might be actively unhelpful to you. So for example, if you're working in dev and you want to test something out, and you say, hey, can you update my dev database? It's going to fail. Or you're asking it to build and deploy your software to staging. It doesn't have the tools to do that. It doesn't know how. Or let's say you have a company-specific question, like, hey, migrate my code to using the company's standard architecture. It doesn't know what it is, so it can't help you. And this is where MCP servers, Model Context Protocol servers, are going to come in. So they're going to provide that help that we need to solve those problems. So in that previous example, what did the AI agent need that it didn't have? There's two main things. One, it didn't have the relevant context. So it was just kind of doing its best, but it didn't know what to do. Or it didn't have the right tooling to perform the useful actions that you need. So that's where the tools that are provided by MCP servers are going to come in handy for you and help you out. So again, Model Context Protocol. I want everyone to know what that is. If you search it now, it might come up with some Minecraft thing. Model Context Protocol, MCP. So this is a new protocol. It was just introduced to the world maybe a year ago, November 2024. So it's a new open standard of communication within AI systems. MCP is going to help LLMs be more effective, tailor them to the needs of your organization or your user base, and it's going to equip these AI agents with the power and the knowledge to solve more specialized problems. So in very simple terms, MCP is a protocol for AI models to interact with external tools. This is a good summary for kind of how this is going to help you. You can imagine it like a universal system agnostic language, something like TCP or HTTP. For AI applications, though. So it's going to enable them to interact with tools outside of an AI environment in a consistent and predictable way. So I want to talk about this in the context of a very specific example and talk about what it can do. So this is an example of how an MCP server may be in action. Let's imagine we're running a Kubernetes command on your machine. I'm sure all of you have experienced a bug or it just crashed or something like that, or did something maybe unexpected. And in that situation, maybe you want to report that upstream. In an AI environment with the proper tools installed, it may be as simple as just asking. So maybe you ask something like, hey, can you create an issue in the Kubernetes repository that describes the bug that I just encountered? Now, going back to what Ty said before about how autonomous agents have to break down these simple tasks into all of the things that it needs to do. In this situation, it may have to figure out, OK, well, what bug just happened? What repo is Kubernetes even in? Like, where is the code hosted? Then it has to create a bug report summary in some kind of format. Then it has to actually create the issue upstream. Then it has to give that link back to you that it generated. So that's a lot of steps. And some of that it can get from the local state, like maybe the details about the bug you encountered, or maybe it can generate a summary, but that might be it. There are a few things in this example that you have to be able to interact with GitHub to do, just plain and simple. So questions like, which repo is Kubernetes in? And actually creating the issue itself. These are going to require interacting with the GitHub platform. So the AI agent can do this through tools provided by the GitHub MCP server, which is available now. Anyone can try it. And if you install it in your environment with your own GitHub credentials, then it's going to be able to provide that tool set to the agent. And you'll actually notice if you look at the MCP tools provided, it looks very similar to the typical API endpoints that you're going to get if you're going to build something yourself. But the difference is that rather than handwriting the code that interacts with every single API endpoint to do a very specific thing that you have to then repeat tons of times for every action you want to do, the agent is actually going to do that for you. So the agent is going to see the request come in, and then its job is to figure out, based on the tools available, what to do and which ones to call. You don't have to tell it. So that's the power that the MCP servers can do when enabled with the right agent. So let's go back to our developer environment example, but we're going to hook in some MCP servers. So here's our original example, again, with the default agent provided by your IDE. This time, let's imagine we've installed a set of useful MCP servers with the necessary tools to help. So let's start with requesting to update a database. So to do this, your IDE is going to set up a client that interacts with that server, and then it's going to be able to configure it and work with it. So let's say that maybe MCP server A has direct access to an instance of your team's database. So now you can just speak human language to your IDE's AI agent, and it'll interact directly with this MCP server to perform various actions for you, like fetches or updates. So that's going to be a lot faster for things like manual testing in dev, or maybe for debugging a production issue. Or let's imagine that you ask your IDE's AI agent to build and deploy your code. Well, to do that, maybe you have something like MCP server B, which has some kind of proprietary steps that's specific to your application that knows which tools that it should use to do the job. So maybe it has an MCP connected to GitHub and GitHub Actions, and then maybe it creates the image and it pushes it to Google Container Registry, for example. So this can be done directly inside the MCP server itself, or you can actually install an MCP server for GitHub and an MCP server for Google Container Registry, and then your MCP server B is actually just an informant to your agent. So it's telling your agent, hey, here's the steps you need to do. I want you, agent, to call the GitHub MCP server, and then I want you, agent, to call the Google Container Registry server. So you can kind of have your server act as a kind of guide for your agent to know what other servers it should use within your system. Or finally, back to our standardization topic, what if you want to migrate your code base to the Mercari standard? Well, in order for the AI agent to be able to do that, it has to know what is the Mercari standard. So it has to have that context that we've been talking about a lot today. And then it can do those steps for you once it has it. So maybe MCP server C's job is just to give that information to the agent. So in summary here, in short, the LLMs are empowering the users to perform actions using human language. And then the MCP server's job is to empower the LLMs to be more targeted and more accurate. OK, we've been talking a lot. Let's do a demo, because I think demos are fun. So I'm going to be showing you how to write one in Go. And you can try this yourself as well anytime you want. And we are going to migrate a code base using an AI agent with a server that we create. So I have an instance of Cursor up. This should look familiar to you for those who have used VS Code or Cursor. We're going to be using this library here. It's github.com model context protocol. It's the Go SDK. So this is the one that's developed by the Go teams. This is kind of the officially supported SDK for servers and clients. So let's go ahead and just make one. So we specify this. OK, we have a server. We'll have it MCP .new server. And then we have an implementation, which has a name and a title. OK? Let's go ahead and do a quick log, and then run server.run. So if you've done any kind of server development in Go, this should look fairly similar. And we'll just say use standard I/O for the communication layer for the agent to communicate with the MCP. OK, so let's show what this looks like in Cursor, kind of out of the box, if you don't have any MCP servers installed. So if you go to Cursor settings, and then you go down to Tools and MCP, you'll see that there's nothing installed. So our job is to install one. I have a very simple script, which I'm not going to show because it's not very relevant. But all you have to know about this is it just runs go build to build the binary that we just wrote. And then it puts a spec file into your Cursor configuration for MCP. So I'll show that now. Let's go ahead and run it. Great, it installed it. You notice this popped up here. So all it did was run go build and put the binary in this build directory here. So you'll see if you can, it's kind of small, but it's in dev talk Mercari years 2025, and then it's the name of the binary in here. So now if I go back to the settings again, we have an installed MCP server. Great. So I'm going to click this little pencil, and you can see this is the Cursor configuration for my entire machine. So all of the instances of Cursor I have up will now have access to this binary. And the command it's running inside the IDE is just the binary itself. So it's this one. It's just pointing directly to that. OK, great. You can see right now it doesn't have any tools, so it's our job to make one. So just as an example, let's create a very simple one. And we'll have it generate a Mercari email address. So you'll run mcp.add_tool. You'll give it the server that you specified, and then you give it some kind of metadata about the tool. So we'll call it generate Mercari email and give it a description. This description is going to be helpful for the AI agent to know what it can do and when to use it. So you want to give it a good description there. OK, cool. So this here is a handler function that we haven't implemented yet. So let's implement that. Then I'm going to come here. That's not what I want. OK, great. I'm using Cursor autocomplete. It looks like magic. It kind of is magic. OK, great. So we have this handler function now. And it uses generics, so you can specify any input and any output you want. For the purposes of this, I want to generate this email params, which I'm going to specify here. And it's just going to have a name, because you have to know the name of the person to give them an email address. So I'm going to have this struct with a name. And then I'm going to take this name, and I'm going to just remove the spaces, replace them with periods, make it lowercase, and then just return it as a text content in this MCP tool call result. So that's this return here. So pretty simple. Let's go ahead and run the script again. OK, great. It installed. Let's restart it. And then we should see a tool pop up. We saw a tool. Great. And it's that generate Mercari email address. And you can see the description and the parameter there, which is the name. So let's go ahead and run it to prove that it works. So I'm going to say, my name is Katie Hockman. Please generate a Mercari email address for me. And now its job is to figure out if it has any tools that it thinks it can help. So let's see what it does. It's planning its next moves. Great. So it found a tool called Generate Mercari Email. It put in the name that I set up here. I could put it in whatever language I want to. So let's run it. You can see that this was the response that the tool gave back. And then it's going to put that in some kind of human language based on the way that I asked it. So great, generated Mercari email, katie.hockman@mercari.com. Very simple tool. Let's make it a little bit different. So I'm going to change this tool. Instead of writing code, let's do what we always want to do instead of writing the code, is just tell it what to return instead. So I'm going to go like this. I'm going to remove the parameter completely. So no more parameters. I'm just going to tell the tool this. So I'm going to say, hey, figure out what the person's name is, make sure you know it, remove the spaces, and I'm basically just using human language to tell the code what to do. So this one I'm going to do in VS Code just for fun. So I have a very similar VS Code install script. So I've just installed it in VS Code. In VS Code, it looks similar. It's just over in the plugins. So in the plugins, there's actually already in here, in case you haven't used it before, an MCP servers installed. So I just installed this one there. Let's start it. Great, it discovered the tool. And let's test it out. Please generate a Mercari email address for me. Let's see if it works. Of course it won't work. It's a live demo. Let me try again. All right, 1 second here. I'm going to do this. And then I'm going to stop it and start it. VS Code can be a little bit tricky sometimes with these demos. OK, so it is running. That's good. Let's just try it again. Please generate a Mercari email for me. Sometimes you have to be nice. It's not going to be nice to me today. So I'll just go back and try it in Cursor again. So please generate a Mercari email for me. I did this in a new window, so it doesn't know my name anymore. So now its job is to use that tool again, but I didn't tell it the email this time, and I removed all of the interesting logic. Did it read the main? It read the main. That's fine. OK, so it's going to run this tool. It came up with a name. That's not the name I want, but that's how demos go. So normally, oh yeah, great. So it actually did figure it out. So it said it generated it, and then to say if you want a different name, let me know. So let's do Thai. And it did it again. Great. So you can do a lot of cool stuff with these tools and make them pretty simple, and they can do a lot within the agent. So we've been talking about standardization. I want to actually show an example of how the standardization might work. So let's make one more tool, and then we'll call it a day. So we will say this one is to use Mercari's recommended code structure. So let's come down here and create that handler. So this handler is very, very simple. It's similar to the one we made above. It just has a text return. So I have this string down here that I saved in advance. It's a ton of text. I'm just going to move it to the top so you can see a little bit more what's in it. So basically, it's just a ton of context for the agent, right? So it's saying, oh, Mercari uses a layered architecture. This is kind of what it looks like. It has this command layer. It has this internal adapter layer. Start by explaining what the structure is, and here's some steps. So I'm just giving human language, then I'm expecting the agent to do the heavy lifting. So let's go ahead and reinstall it into Cursor. And then I'm going to make sure that's saved. I'm going to do it again. OK. So if I restart it, I can see it has two tools. So I have this repo over here that I want to test that tool in. This is just a repo that I found online. My friend Dimitri made it. It's a Go package manager that has a front end, and it has various components like access to GitHub. It has assets, commands, things like that. So I want to see if I can make this code migrate to the Mercari standard structure. So I'm going to show here. It has those tools installed. Great. So it has that use recommended code structure. So let's go ahead and try it. So I'll say, please migrate this code to use Mercari's standard structure. And now we just leave it to the agent to see what it's going to do. So it has to figure out the tool. It found the right one. So you can have as many tools as you want. It'll figure out which one is relevant. And you can see that the response is just a ton of text. There was no input. Now, this is all context that the agent didn't have before. then now it has it. So it's going to go and it's going to do whatever it wants to do. So I'll talk as it runs. So it's going to go through and it's maybe going to start reading the code. I put an allow list for a couple of commands that I just let it do without my permission, but only a couple of them. So things like doing a CD or moving files, things like that. So I'm just going to let this be an autonomous agent for us while we talk about it. So Raphael was talking about this previously too, where migrations are very hard, they're very costly. And Ty was also talking about this in the context of it being kind of a cold start problem. It's only really useful if you have a ton of people, yeah, sure, you can copy, a ton of people using this standard structure. And it can be really hard to justify this to leadership too, because it's very expensive, and maybe it doesn't generate value immediately. So if we can have tools that can do this for us, even if it's not perfect, it can give us a start. So it's going through and it's just going to start doing whatever it decides to do. And it looks like it's doing pretty good. So it moved a couple of things already. It's still moving stuff. So now we have this internal. This looks very similar to what I had recommended that it do. And it has this adapter. It made the infrastructure. And it separated the code out in the way I wanted it to. So it put this type interface in the domain, which is what I wanted. And it didn't change any of the code itself. It just moved it around. Now we have our command. Great. We have our go package store command. And it can run as long as you want. I'm going to stop it because I want to show what else it can do. So I'm going to say, no need to change any more code. Can you just tell me about this new standard? Why is it useful here? So Ty was also talking about this being a knowledge bridge. It's useful to have a tool that can help you so you don't always have to ask a person if you don't want to. And now it can just tell you something that documentation can't. Documentation is going to be pretty generic. But in this case, it's like feeding documentation into a person or an agent in this case. And now the agent can give you very directed answers. Well, this is your code, and this is why this layer is useful, and this is why I made this decision. And you can ask follow-up questions, and you can say, oh, this is going to make it easier to maintain, things like that. So yeah. That is an example of how you can kind of start to use MCP for migrations and standardization. Okay, thank you. Okay, so where does this go wrong? That might be asking. It might seem a little bit magical now, but it can go wrong, and it's not perfect, as many people have talked about today. So when I was developing this internally and trying out tools, these are some of the problems that I noticed. You may have noticed other challenges yourself. So one such struggle is with very, very large spread out code bases. In my experience, if there's a ton of directories and a ton of very small files, it can be difficult for the agent to kind of get all the context. So sometimes it does better with smaller code bases or even just with fewer files that are large instead of a lot of small ones, but it really depends on what you're trying to do. We also found that AI doesn't always choose the most efficient strategy. So in this migration, for example, it had to change a ton of import paths, right? Because the file moved to a different directory. So any internal references have to have a new import path. When I was doing this at first, I was noticing that it was manually looking at every single file one at a time, line by line, and fixing every import. Not very efficient, but I was able to teach it, oh, actually, please just use these terminal commands like grep or sed that can just do it for you. So you actually have to teach it sometimes to use the efficient strategy. And lastly, as you noticed here, all the MCP server did was provide tools and context. That's it. Most of the heavy lifting came from the AI agent itself. So no matter how great the tooling is, if a user doesn't have a very good model that it's using, there's not that much you can really do as an MCP tool developer. So really, the servers are just providing the tools, and then the AI agent is deciding how to use them or when to use them, and it's doing the heavy lifting. So you do want to have a strong AI model. And now we're going to go back to Ty to wrap us up and look at the future.
Thanks, Katie. Now I feel like I can build an MCP.
Yay.
So as Katie highlighted, the output of AI is often inconsistent, and ensuring consistency and reproducibility is one major challenge in utilizing AI for development. We are actively exploring ways to make AI agents work in a more consistent way, including how we provide organizational context, such as company standards to AI. This challenge is broad in scope. We are continuously exploring ways to manage our knowledge, including how we make implicit knowledge hidden in experts to explicit knowledge that's shared with everyone. Another aspect is how to enable AI agents to autonomously take actions while ensuring quality and security. Yes, we are tackling some challenging and truly exciting problems at Mercari. These new challenges demand that we collaborate across domains more closely than ever. We are already using AI tools such as Notion AI to make that collaboration better. We are finding that with the power of AI, the boundaries between domains become more fluid. This enables each of us, regardless of our specific role, to more effectively learn other domains and step out of comfort zone. All right, let's wrap up. We'd like you to take away 3 concepts from our talk today. Firstly, context is the key. To use AI as an autonomous agent and make it behave in a consistent way. For that, knowledge management and finding an effective way to feed organizational context to AI, including MCP, are crucial. Secondly, this creates a win-win relationship. We can leverage AI to scale our standardization efforts, and having that common standard in turn helps AI to reliably meet our quality expectations. And finally, tackling these challenges requires a new mindset. We must be willing to experiment, learn from our failures, and actively share our findings. This is the foundation of what we call our AI native culture at Mercari. Thank you for listening to our talk. I hope you all enjoyed this year's Mercari Gears and found something inspiring.
Thank you so much, everyone.
KT さん、タイさん、ありがとうございました。Thank you very much.